I'm now going to do part B of this problem. So recall, the problem we're trying to solve is problem 32 from the textbook, which states a rifle is aimed horizontally at a target 50 meters away. The bullet hits the target 2 centimeters below the aim point. A, what was the bullet's flight time? And B, what was the bullet's speed as it left the barrel? I began by drawing a figure where I labeled the relevant information that we were given. And then we set out to solve part A. And what we ended up finding was that we could use one of the vertical motion equations to solve for the time. Now we'll do part B. So, pro tip, if part A needed the y motion, part B is probably going to need the x motion. It's not always going to be true, but it's probably a good guess. They're probably going to try and make sure you understand all parts of the problem, and so they'll ask questions that involve all the different bits. So let's look at the equations for the horizontal motion. So recall, the horizontal motion is motion with constant speed, and so the x-coordinate velocity doesn't change during the motion, and the x position just increases linearly. Well, it's unlikely that this first equation gives us anything useful. The second one, however, looks promising. So if I think about the final time, this is just x final, this is x initial, that's the initial velocity times time. Well, hey, we know everything in that equation except for the initial velocity, which is exactly what we need to solve for in this problem. So we're more or less done. So I just write this as x final minus x initial equals VIXT. Okay, this is what we were calling delta x. The x component of the initial velocity, that's the same as the initial velocity, because it's horizontal. Time. So the velocity is just the distance gone over the time. Motion with constant speed. I can plug in numbers. 50 meters over 0.0639 seconds. And then I plug that into my calculator, and I get that the initial velocity was 782 meters per second. Now, I don't know a lot about bullets, so I don't know how reasonable that is. According to Wikipedia, this is a reasonable muzzle velocity. These projectile motion problems are difficult. There's a lot of moving parts. There are a lot of different equations. And there are a lot of concepts. The best way to master these types of problems is to do a lot of them. Please come to office hours, ask questions on the forum.